निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students. In this session, we will be studying regarding chapter 12, HERON's formula, the introduction part of exercise 12.1. HERON's formula. Before moving on to HERON's formula, let us revise something that we have gone through in our previous classes regarding triangles, regarding area of triangles. How we used to find area of triangles in our previous classes for different types of triangles. The basic formula for a right angled triangle, suppose this is my right angled triangle A, B and C, and the triangle was right angled triangle. This is a symbol for triangle. Right angled triangle. Right angle means one of the angle is 90 degrees. So suppose let us take this one as 90 degrees, that is given to us. In any triangle, the two sides corresponding to the right angles, one can be considered as a base and the other can be considered as a height. So let us consider this one as base and this one as height. And this was our hypotenuse. Now to find the area of a triangle, area means that is the part that is enclosed within the figure. The total part, this part is considered to be my area. The area enclosed by all the three lines of the triangles. So this part is called area of a triangle. Now how do we use to find the area of a right angled triangle? That is always we are given the basic formula. That is area is equals to half into base into height. This was the basic formula that was given to us for any right angled triangle. Let's take an example how to find the area of a right angled triangle. Suppose we are given with a right angled triangle and this one is 90 degrees, and suppose the base is 8 centimeters and the height is 10 centimeters. What is the area enclosed between the triangle? The area enclosed between the triangle can be very well found out by this formula, that is area is equals to half into base into height. So we could have found area is equals to half into, let us B be the short form for base and H be the short form for height. And this is just substituting the base and height, is half into base here we consider as 8 in comparison to what we have seen in the previous figure. This is half into 10, half into 8 into 10, and the unit will be centimeters square. So if you simplify, this is 4 and we could have it as 40 centimeters square. This is the way we used to find the area from the basic formula of area of a right angled triangle. Those triangles whose one of the angle is 90 degree, and that was given by area is equals to base half into base into height. But whenever we talk about a right angled triangle, we always remember a great mathematician. That is what we named him. The name of that great mathematician was Pythagoras. And his theorem that has been given to us is applicable for a right angled triangle. So what was the Pythagoras theorem? Just taking with this part of the subject only, so that in the further part, if we use the theorem, you will be very clear what was the theorem of Pythagoras that he gave. This is my right angled triangle, this is base, this is height as we have discussed, and this is my hypotenuse. Let us give the short names. This is B. Let us give the short name as small h. For the hypotenuse, let us take as capital H. According to Pythagoras theorem, in any right angled triangle, a right angle triangle. In a right angle triangle, base square plus height square is always equals to hypotenuse square. If two of the sides of a triangle are given, the third side can be found out using Pythagoras theorem, and the Pythagoras theorem is given by the base square of the triangle plus height square of the triangle is equals to the hypotenuse square of the triangle. Let's go to an example also where two sides are given to us and we need to find the third side. Suppose we are given a right angle triangle whose one of the side is say 6 centimeter and the second side is 8 centimeter, and we need to find the hypotenuse. You can find any side if two are given to you. Here we have taken the base and height to be 6 centimeter and 8 centimeter, and we need to find the hypotenuse. Applying the Pythagoras theorem, if we go through, we are given with base square plus height square is hypotenuse square. So base is 6, so this is 6 square, plus height is 8, this is 8 square, and we need to find the hypotenuse. So 6 square is 36, 8 square is 64, and this is my hypotenuse square. So we can write hypotenuse square is equal to sum of 36 and 64, that is 100, and height is equal to root under 100. If you remember your equations that we have solved, simple equations in class 8, chapter 2, linear equations in one variable, where whenever we were changing the sign of a particular number to the other side from left hand to right hand or right hand to left hand, plus sign used to change to minus, minus to plus, multiplication changed to division or changing the sign, and division changed to multiplication or changing the sign. Same is the case if you want to take here. This is a square. If you change the sign, it becomes square root. Here it is a square root. If you change the sign, it becomes the square. So all on solving root under 100 that we have learned in class 8 how to find the root in the chapter squares and square roots. So root under 100 is 10 centimeters. That means the hypotenuse of the given triangle that has been given to us with two sides 6 centimeter and 8 centimeter. The hypotenuse we have calculated to be 10 centimeter using Pythagoras theorem. Keep in mind the Pythagoras theorem is only applicable for right angle triangles. So our main topic was to discuss the area of the triangle, because since we are dealing with the right angle triangle, this is a very important theorem where we will be using regularly in our chapters, or we are using it for finding the sides of a triangle whenever required. So moving on to our main part, right angle triangle, the basic area formula is given to us as half into base into height. Then there are various types of triangles. There are equilateral triangles where all the three sides are given. There is isosceles triangle where two of the sides are known. That is, one is the equal sides and the second is that is not equal to the previous side. And then we have scalene triangle. Then what are the formulas that are required to find the areas of such type of triangles? Equilateral triangle, isosceles triangle, or scalene triangle, or what are the methods or what are the steps that we follow to find the area of such triangles? So in this chapter, we will be dealing with such triangles whose areas are to be found out, but an important part will be our HERON's formula. Next triangle, let us move on with all such triangles, equilateral, isosceles, scalene one by one. Suppose first we are dealing with equilateral triangle. We are taking an equilateral triangle XYZ, where XY equals to YZ is equals to XZ is equals to say 8 centimeter we would be considering, and we need to find the area of this equilateral triangle. What we used to do is, we used to first of all compare it with our right angle triangle. We don't have a right angle triangle here, so we will have a requirement of an altitude and height, so that half into base into height can be applied here. And where is the altitude? So we will have to draw that altitude. Say this will be P. Now we have drawn an altitude. We will have to draw XP perpendicular to YZ. Now this one is given to you as 8 centimeter. This is also 8 centimeter, and the whole XZ is also 8 centimeters. In an equilateral triangle, there is a speciality of equilateral triangles where the median and the altitude are the same. That means the median and the altitude. What is median and what is altitude? Median means that line that divides the line into two equal parts. That means here we will be having yp is equals to pj. It is called the median that will divide the place on which it is coming into two equal parts. So here in an equilateral triangle, since we have drawn the altitude as xp by our construction, but that altitude also behaves as a median dividing yz into two equal parts, that is yp and pz, and that total was 8 centimeters, so each will be 4 centimeter and 4 centimeter. Now we have, for applying the area of a triangle half into base into height, we have a base yz. We don't have that height that is required, and that height can be calculated how? If we consider triangle XYP, only triangle XYP, how can the height be calculated? That height can be calculated as we have discussed here, that we will have to apply Pythagoras theorem when two of the sides are known to us and we need to find the third side. So we can say according to Pythagoras theorem, let us see how it works out. According to Pythagoras theorem, where we are applying in triangles say x, y and p. If the triangle is x, y and p, according to Pythagoras theorem, we know base square plus height square is hypotenuse square. What is our base here? Yp square, that is yp is the base. Xp square, that is my height. And what is the hypotenuse? Xy. Xy is the hypotenuse. Hypotenuse is always the longer side, the side opposite to 90 degrees. Putting the values that has been given in the triangle, xp is 4, so this can be 4 square. xp square, we are looking for xp square. We have substituted the value of yp square, that is 4 centimeter. xp square is to be found out. Then what is xp square? We need that one as this is the height that we are looking for. So let us keep xp square as it is. And xy square is given to us, that is 8 centimeters. So this can be written as 8 square. Solving, we would be getting the value of xp, the height that is required to us. This is 4 square, 16 plus xp square is equals to 8 square is 64. Take the 16 to the other side for simplification, as we have done in linear equation in one variables. So xp square is 64 minus 16. So xp square can be written as 48, and we need to find the square root of xp now. If we remove the square part to the other side, so this is 248. And this also finding square root we have learned by factor method. If you find the factors of 48, you get 2 into 2 into 2 into 2 into 3. This we have done in class 8, when we used to make pairs and we used to take out one number from the given pair. So here we can write from this pair 2 into 2, and 3 is a single digit, it is not in pair, so this remaining as it is. So this will be, so this can be written as 4 to 3 centimeters. Now we have got the height from the equilateral triangle that we were looking for. We have the base as yz. Now applying the basic formula for a triangle, that area is equals to half into base into height. So this is half. We have base as yz and we have height as xp. So now the area can be calculated as half into yz, we have 8 centimeters, and xp we have calculated 4 root 3, and the total answer will come in centimeter square. Simplifying, we will be getting 16 root 3 centimeters square. This is the way how we used to find the area of a equilateral triangle. This is the way, the steps, the method, whatever you say, the way of finding the area of an equilateral triangle by our using basic formula half into base into height. But we have one more thing that we have to keep in mind. A direct formula for finding area of any equilateral triangle. Let me give you that. Wherever required, you can use also. Area of equilateral triangle is always equals to root 3 by 4 side square. Side can be the side of the equilateral triangle. If you move on in this way, that is also very correct. If we directly use the formula, then also it's correct. Let us check the area that what we have got by our method, whether we are getting the same area by formula or not. So we need to substitute only the value. Root 3 by 4 is a constant value, we need not change it. And side square root is our side out there of the equilateral triangle, that is 8. So we can put here 8. And that is square, so 8 into 8. So if we cancel it, 4 2s are 8 2s are, this is again 16 root 3 centimeters. So we are getting both the answers to be same. So we can move on with any of the method we want to find the area of an equilateral triangle. The next triangle is isosceles triangle. How do we find the area of an isosceles triangle? What we have learned in our previous classes, area is half into base into height. But there is again the height is missing. We have considered an isosceles triangle ABC, where the two sides which make it isosceles are AB and AC. That is, AB is equals to AC is equals to 5 centimeter, and the third side that is not equal to the previous sides is 8 centimeter. Let us consider this isosceles triangle to understand how to find the area of isosceles triangles. Again, here also, for half into base into height, we are given in the base and we don't have a height. So let us draw a perpendicular. Name it as P. Now AP is the perpendicular or BC that we have drawn. So let us take draw AP perpendicular to BC. We have drawn an altitude. It is the same as an equilateral triangle that when a perpendicular is drawn from the point of intersection of two equal sides to the third side, that side AP is median also, as well as this is the altitude also, the height also. So again, this will be the median AP, that means that will divide BC into two equal parts. BP will be equals to BC. The whole BC was 8 centimeter, so BP will be half of 8 centimeter, that is 4 centimeter and 4 centimeters. Now again, if you observe, we have a right angle triangle ABP. Right angle triangle ABP, where two sides are known and the third is unknown, and the third is the height that we are looking for. So that means we will have to find out the third side using Pythagoras theorem. So let us move on with Pythagoras theorem. So by Pythagoras theorem, applied on triangle ABP, we can write base square, that is BP square, plus height square, that is AP square, is equals to hypotenuse square, that is AB square. Substituting the values from the triangle, we can find AP. So BP is given to us as 4, so this is 4 square, plus AP square, we are looking for, as this is the height that we are looking for, and AP square is 5 square. So this is 16 plus AP is equals to 25. AP square. So AP square is 25 minus 16. So AP square will be equals to 9. So AP is equals to root under 9 as we have done previously. And AP is 3 centimeters, and the square root of 9 is 3. Now we have got AP to be 3. We have base to be 8 centimeter BC. We have a base, we have a height. Now we can find the area of the triangle. So area of isosceles triangle ABC area of triangle ABC is given by half into base into height. Here, half and base. The base for our triangle ABC is BC, and height for our triangle ABC is AB. And then substituting the values, half into BC is 8 centimeters, and AB we have got as 3 centimeters. The unit of the area will be centimeters square. Solving and getting the answer. This is 4, so this is 12 centimeters square. This way, we find the area of an isosceles triangle. Next triangle, scalene triangle. Scalene triangle means whose none of the sides are equal. We are taken with a triangle ABC, where AB is not equals to AC is not equals to BC. All the three sides are not same. When all the three sides are not same, they are considered as a scalene triangle. All the three sides are not equal. Then what are it? Let us say this side the value is A. Let us say this side the value is B. You can take any values, and the third side as C. A, B, and say that this is the three sides of the triangle, and A is not equals to B. A is not equals to B, and it is not equals to C. If they are equal also, we can consider if A is equals to B, then it becomes an isosceles triangle. If all the three are equals, it becomes an equilateral triangle. We are presently dealing with scalene triangle where none of the sides are equal, but the sides are known to us. Then how can we find the area of a triangle? Let us take some values here so that it will be easy for you. Or else, let us first of all move on with the formula for finding the scalene triangles. Here comes our topic, HERON's formula, a method that HERON's gave us to find the area of any type of triangle whose three sides are given. His formula is applicable to all types of triangles where the three sides are known. It is also applicable for equilateral triangle, it is applicable for isosceles triangle, it is applicable for scalene triangle. So for all the formulas, for all the triangles, we are given with a formula, HERON's formula, to find the area of a triangle. In many books, it is also written as HERO's formula. Actually, this is a HERO formula only because it can help us to find the area of all the types of triangles whose sides are known to us. Then what is the formula that he has given? He first of all told that find the semi-perimeter of the triangle. We need to find first the semi-perimeter of the triangle. Semi-perimeter of the given triangle, and that is denoted by small s. Semi-perimeter. What is perimeter? Perimeter means which is the boundary of any figure. Here, since we are talking about triangle, here perimeter means it is the addition of all the three sides of the triangle. Side A, side B, and side C. And semi means half. So semi-perimeter means half of the perimeter of the given triangle. Then what is the semi-perimeter for the triangle ABC that we have written? That is side A plus B plus C, and 4 divided by 2. Semi means half, so we have divided by 2. So first of all, we will have to find the semi-perimeter of the given triangle whose area is to be found out. And then we need to substitute in another formula, that is area of the triangle ABC as from our figure that we are naming it, and is given by S into S minus A, S minus B, and S minus C, completely taken under and the value. By solving this part, you will get the area of the triangle directly. You don't have to move with half into base into height. You don't have to move with the formula of equilateral triangle, move 3 by 4 side square. A simple method, find the semi-perimeter of the triangle whose area is to be found out, and substituting the values of A, B, and C and S in the formula of area of a triangle, you get the area of any type of triangle that is asked to. Let us consider an example also with the Hebrew corrector. Let us take a triangle with sides say 3 centimeter, 4 centimeter, and 5 centimeter. And this is a right angle triangle. If you see 3, 4, and 5 are Pythagorean rectangles. This square plus this square plus this square. But we will be following the method of Heron's to find. Very easily we can find the area of this triangle by half into base into height. Half into base into height. Half into 4 into 3, and we will be getting as 6 centimeters square directly by the method of half into base into height, which is applicable for a right angled triangle. But if we move on with Heron's formula, how can we find out the area of this given triangle? By Heron's formula, we need to find S and we need to find area of triangle. But before that, we need to know what are A, B, and C. So we can consider any of the sides to be A, B, or C. You don't have to make an exception that only this is A or this is B or this is C. You can take any side to be A, any side to be B, any side to be C. So let us take here. Say A is equals to 3 centimeters, B is equals to 4 centimeters, and C is equals to 5 centimeters. Moving on with the method of Heron's formula, the very first thing that we need to find is semi-perimeter. So let us find semi-perimeter. S is equals to A plus B plus C whole divided by 2, and substituting the values of A, B, and C. So this is 3 plus 4 plus 5 by 2, and 3 plus 4, 7, 7 plus 5, 12, 12 divided by 2, and this will be equals to 6 centimeters. Now we have got the semi-perimeter S, we have A, B, and C. We just need to substitute in the formula by Heron's area of any triangle. So here the area of the triangle that we have taken as an example, that is S into S minus A, S minus B, S minus C completely, and we'll be just substituting the values of S, A, B, and C, and we'll be simplifying it in order to get the area, and then we'll be checking whether the area is correct or not. So let us move on. S was 6, then 6 minus A we had taken as 3, this is 6 minus 3, then 6 minus 4, and then 6 minus 5 for the values of A, B, and C. The answer that we will be getting will be centimeter square. So this is 6 minus 3 is 3, 6 minus 4 is 2, and 6 minus 5 is 1. If you split 6, you get 2 into 3, you have 3, you have 2, and 1. Anything multiplied by 1 is 6. So we make pairs, so this is one pair, this is one pair, and out of the pairs we get 1, 1. So this is 6 centimeter square. So we have got the area of the triangle by Heron's formula as 6 centimeter square. We have also got the area of the right angle triangle because we took this one as a right angle triangle. There also we got 6 centimeter square. Both the areas are same, means both the formulas are applicable. Heron's formula is a very specific case for finding area of any triangle. Area of any triangle, whether it is an equilateral triangle, isosceles triangle, scalene triangle, maybe right angle, may not be right angle, but it is applicable to all the triangles whose 3 sides are given to us.